In this video, we will perform the experiment which is to convert a micro-ammeter into an ohm-meter of different ranges. And when we convert this micro-ammeter into an ohm-meter, so because ohm-meter is the device to measure the resistance, so we will use that ohm-meter converted one to use it to measure the unknown resistance. So basically this is to convert a micro-ammeter into an ohm-meter, and then using that ohm-meter we will try to measure the value of the unknown resistance. The apparatus which we need is a battery eliminator. So you can see this is my battery eliminator, and then we need of 1.5 volt micro-ammeter. So you can see this is my micro-ammeter, DC micro-ammeter of range 500. It's important, 500 micro-ammeter range. And then what I need is two resistance box. So I need one resistance box and the other resistance box, and then I need a carbon potentiometer of 10 kilo ohm value. So this is my carbon potentiometer. This is knob through which we will vary the resistance inside this of 10 kilo ohm. And then we need 4 unknown resistance. The resistance is connected between these terminals whose value we don't know, so we have to find the value of these resistance, because you can see the resistance is connected in between this. We don't know the value of this resistance, so we can measure the value of this unknown resistance once we convert this micro-ammeter into an ohm-meter. So this is what we have to do in this experiment. The circuit is very simple. You can see this is the 1.5 volt battery eliminator. The two resistance box are connected. One is RK, name as RK, and one is name as RA. And this is my carbon potentiometer. This one is carbon potentiometer, which is this RB variable, and this is my micro-ammeter. So this is my micro-ammeter. So you can see the circuit, how to connect the circuit. You can see this resistance box. If I choose this resistance box, so we have resistance box have 2 terminal. One resistance box, this is also going to have a 2 terminal. Okay, so you can see this wire which is coming from the one terminal of the resistance box is going to the positive of the RV, and the other one is going to the positive of the terminal. Okay, so we can choose that. So if you choose this terminal of one terminal of the resistance box, so one you can see these 2 wires. So you can see one wire, this is from this terminal, is going to the positive of the eliminator. This is battery eliminator. So this is going to the positive side, and the other one will go to the positive of the carbon potentiometer. So the one goes to you can see this is the positive of this, and the another one is we see connected to the carbon potentiometer, the positive the carbon potentiometer. So this part, you can see this part is done. Okay, this part is done. Now the negative of the or you can see the other terminal. So this terminal we have connected for this terminal. So this terminal, one is going to the negative of the micrometer, and the another going to the one terminal of the resistance box. Okay, so 2 wire which will come from here. This 2 wire which is coming from here, one is going to the negative of the micro-ammeter, and the another one is to the other resistance box. So you can see this 2 wires. So one wire, you can see this is going to you can see this is going to the negative of the micro-ammeter, and the another one is going to, you can see here, so another one is going to the another resistance box. Okay, so this is very simple. So this one is going to the negative, and this one is going to, and the another part of this the other resistance box is going to the negative of this. So this one is coming from here, so this another is going to this negative of the battery eliminator. Fine. And then from this positive of this negative goes here, so the positive of this going to the negative of the carbon potentiometer. So this positive is going to, you can see this is the other connection of the carbon potentiometer. So this is what a very simple connection. Now the circuit is complete. Now let's go to perform the experiment. So the table of observation is like this, which is the calibration, known as the calibration observation. So the first part is the current, which will measure from the micro-ammeter, which will be I, okay, and then the value of RK. You find is the RK is, you have to name RK and RA. So this is my RA, this is my RK, fine. So what we have to do, this is value of RK, we have to fix the value of RK different, and we have to vary the value of RA using here. These are the value of RA and these are the value of RK, okay. And then what we have to do, first, let's put the value of RK 100 ohm, okay. So RK is this one. So let's put the value of RK. This is, you can see this is 100 ohm. Before performing the experiment, make sure that all the connections are tight, okay, very tight, not to be loosed. So now I'm going to get the value of RK is, this is 100, you can see 100. I have introduced the current resistance 100. So this is RK 100. Now when we on the eliminator, so you have to pass on the 1.5 volt of the current in the circuit. You see the deflection. So the RA is not having any resistance, 0 resistance. RK we have 100 ohm resistance, the deflection in this. And now what you have to do, I have to with this carbon potentiometer, I have to make the deflection full. Maybe this is, you have to make the full deflection. So this is full deflection, this is the full deflection using this potentiometer. Once you do that, you made the deflection, full deflection. Now what you have to do, I have to introduce the value of, because you can see RK value is 100, okay. So there is no value of RA, no value of RA in the resistance box, okay. So that means this RK is 100, no value of RA. Now what I have to do is, then the current in the micro-ammeter is full deflection, this is 500, okay. So make it 500, this is full 500, okay. So the current value is 500, value of RA is 0. Now take the value of RA is 10. So let's take, this is value of RA is 10, take 10 out of. So you can see what is the value of this, and this is like 450, okay. So now you had to note down at 10 value, this is becomes 450. Now we have to choose the resistance so that it becomes 450, 400, 350, the value of current. Now if we make it like, if we make it 20, say this is 20, okay. So this is still, it's not 400. Let's make it 5 more if this. So this becomes 400, 500, 450 and 400. So now you can see when we put the value of RA 10 ohm, it's 450. Now for 25, this is 20 and this is 5. For 25, it is 400. It's okay. So this is 400. Similarly, if we choose another values, so like this is like 20 is already there, 20, this is 40. So I have to make it like 350. So you can see this is 350. So like here is for 43, I have made it like for 40, it becomes 350. Okay. So in the same way, we have to keep on finding out the resistance for which the value of the current from 500, from the full deflection, it becomes 0. So keep on increasing the resistance value in the RA, fixing RK value 100 ohm. You find out the resistance so that the value of current in the micro-ammeter becomes 0. Okay, you can see the how high value it goes. Like if I make it like, you see, let me do it. If I'll make it 20,000, you can see it's still not 0. So like it's 20, it's still 20. So like it's 21,110, it becomes 0. So you have to choose, keep on choosing the value of RA, so the value of current becomes 0 for the fixed value of RK. Fine. Now this is for one observation. Now I have to do is like in place of 100, I choose the value of RK 1 kilo ohm. So this was earlier, this was 100 ohm. Okay. Now I have to choose the value of 1 kilo ohm. So you can see 1 kilo ohm, that is 1000. So I'll make it 1000. Okay, 1000. Now again, after choosing this, RA is 0, no resistance reduced. I make it 1 kilo ohm, and then by choosing this, I have to make the full scale deflection. You have to make the full scale deflection. Okay, get a full scale deflection. So for RK, for full scale deflection, current is 500 microampere, full scale deflection 500 microampere. Now again I have to introduce the value of the resistance in our RA, so that I get 450, 400. Like here it says 120. If I make it like this is 100, let's see. It's like when I choose 100, it is like still like 450. Okay, so when I choose the value of resistance 100, it will become 450. So in the same way, we had to choose the value of RA from this resistance box, keeping here value 1 kilo ohm, and then we have to choose the value of resistance so that this becomes 0 again. In the same way, when you do this, now replace this 1 kilo ohm to 10 kilo ohm and find out the resistance, and then try to put the value becomes 0. Okay, so one thing you keep in mind, that you have to smartly choose that value becomes like this, or you can choose that doesn't matter, because why we choose like this, because we have to plot the current and the corresponding this value, so that the life becomes easy. If the both these are very variable, there's plotting becomes slightly difficult. So that's why it's not necessary it becomes 500, 450, 350. You can choose any value of resistance, but what you have to do is you have to decrease gradually so that it becomes 500 to 0. So once you do this, what you have to do is you have to plot the value of current I and the omega, this RV. So you can see that what you have to plot is on the y-axis you have to plot the current I. This is 500, 450. So this is 0 to 500, and then the corresponding value of this for 3 different values: 100, 1 kilo ohm, and 10 kilo ohm. So you can see that 3 graph is there. This is RA value, and these are for the 3 different RK values, and for this current I. Okay, so this will be for 100 ohm, 1 kilo ohm, and this will be the 10 kilo ohm. Three graphs we will get for I on the y-axis and RA value on the z-axis. So this is the one part through which this is the calibration graph. Okay, now let's move to the second part. In the second part, what we have to do is in place of RA, we have to introduce the unknown resistance. These 4 unknown resistance. These will be known as the RV, unknown resistance. So this is my RK, this is my RA. So in place of this, we have to introduce these values. So first, what I have to do is we have to take out this from the circuit, or make it 0. First make it 0, because if you have no resistance, so then this is already 0. Now the important point is now we are not going to get the resistance from out of here. We'll get the resistance, put the resistance, these 4 unknown resistance in place of this value. So let's start with the second table. Second table is this, where we are going to measure the value of the unknown resistance. What we have to do is we have to first fix again the RK 100 ohm. Again I am going to fix this RK to the 100 ohm. Okay, so there is no value in the RA. Okay, so this is 0, and then if you on the circuit, you have the deflection here, and then make a full deflection from using the potentiometer. So make the full deflection carefully. Fine. So once I do this, so putting RK, this is 100 ohm, and then RV is 0 still, no resistance is here, and we make the full scale deflection. We made the full scale deflection. Now what we have to do is introduce, in place of this, we have to introduce these 4 resistance. So let us open these wires. These 2 wires are now going to attach to these resistance values. So now I'm going to attach to these resistance values. So this wire also here. So let me make the connections. so you have to make the connection tight, steady. So now I have introduced this resistance in the circuit. So when I introduce this resistance in the circuit, so say these will be these four resistance will be like R1, R2, R3 and 4. These resistance are unknown to us, okay. And what I have done is keeping the value of RK 100 ohm, making the full deflection. Now what I have to do is, like, we have to know the value of the current in the circuit, in the micro-ammeter. So when I put this supposing this is R1, this is R2, this is R3 and this is R4, try to see what is the full scale, what is the deflection in the circuit. So this is like, you can see this is like, this is 450, 450, 52 and this is 490. So you write down, for this is for R1 value, you write down this is 490 value, okay. And similarly, if we get from here, if we detach it from here, try to make this connection 0, so there is no resistance introduced, and then so no resistance is introduced there. Then make again the full scale deflection. Make again the full scale deflection. Be careful about making full scale deflection. And then again you take these two wires and connect to the R2 value. So when you put it in the R2 value, you can see, you can measure the value of this deflection. This is like 150, like 280, 180 value, okay. This is 180. So you note then for the R2 value 180. Similarly, you detach from here, short the circuit, and not short the circuit, make these two wire connected to each other so that the no resistance introduced. Make the full scale deflection using RV. Then again choose these two resistance, R3. Note down the value of the deflection here. Note down the value of deflection for the R3 value. Similarly do for the R4. For R4, note down the value of deflection, okay. So for this value of 100 ohm, choose these value of unknown resistance and try to find out the deflection in the micro-ammeter. Note down these values. Forget about this right now. Now fix the value of RK in place of 100. In place of 100, make it 1000. Make it 1000. 1 kilo ohm. Again choose the value of R1, R2, R3. When you make it 1 kilo ohm, when this is 0 here, make the full scale deflection. Choose the value of R1 here. Make the connection here, and then note down the deflection in the galvanometer. R2, note the galvanometer. Choose this R1, R2, R3 and note down the deflection in the micro-ammeter corresponding to these four values of the unknown resistance. Similarly, take the value of RK in place of 1 kilo ohm, 10 kilo ohm, make it the full scale deflection and choose the value of R1, R2, R3 and R4 and note down the corresponding value of the micro-ammeter here. For the R1, R2, R3, choose the value of the micro-ammeter deflection here. Now once you are done with this, what you have to do is, this is your calibrated graph, where you have plotted I on the y-axis and R on the z-axis. Now what we have to do is, like, if we choose for R is equal to 100, RK is equal to 100 ohm. So this is the graph for the RK is equal to 100 ohm. This is for 1 kilo ohm. This is for 10 kilo ohm. So RK is 100 ohm. What you have to do is take the value of current for this 170 for this R1. So this is R1 value. I have taken R1 value. Forget about this. For R1 resistance, my current is 170. So choose the value of current, go to the 170 value, draw a line where it cuts the graph and come to find out what is the value of R on the y-axis and note down here. So this is, you can see R from the curve, okay. So whatever the value of current, choose on the y-axis and corresponding find the value of resistance on the x-axis. For this value, this value, this value and this value. Similarly for 1 kilo ohm, for this current, go to the x-axis, choose the value of current and draw a line where it cuts, and then go to the corresponding resistance value on the x-axis and note down here. Okay, fine. Now once you note down the value of R from the resistance, you have to find out the most probable value of the unknown, these four unknown resistance. You can see for this case, here is 200, here is 200, here is 200, here is 200. Okay, for this case 200, 200 and 200. That means the value of this unknown resistance R, this R1 is most probably is 200 ohm, because these 200 are coming from all these three graphs. Similarly, in this case, you see here we get 510 values, 510 here, 520 and 530. Here we get a 530 value. Okay, so the most probable value of this is going to be 510. Take the mean of this. Similarly, for the third R3, you get 900, 1020 and 1000. You take the mean of this. The value, most accurate value of this R3 is going to be 1 kilo ohm. Similarly, for this is you get 1500. You get also 1500 here. In this case, in this is also 1500. The most probable value of this R4 is going to be 1500 value. So now in this way you find the most probable value of these R1, R2, R3 and R4 by measuring the corresponding current here for these three conditions and taking the value of R from the calibrated graph which we have plotted on the basis of this calibration observation. So this is how you do convert a micro-ammeter into an ohm-meter, and you find out the value of the unknown resistance R1, R2, R3. This is comes out to be this much: 200, 500, 1000 and 1500. And this all observation and your findings have to be there in your result, that you have converted the voltmeter into milliammeter into an ohm-meter, and using the calibration graph you have tried to find out the value of the unknown resistance, and they are come closer to the value of the actual resistance which we have used, R1, R2, R3 and R4. And this is all you have to do in this experiment. Thank you.